In this video, we're going to take a look at vertex form of a quadratic function and see how we can use completing the square to find this vertex form. So we've talked about transformations of the graph y equals x squared, which we know the graph is a parabola. We can move it up, down, left, or right, flip it, and do all these things. And this is a form here that will get us any parabola we want. This a value out here, we know that this flips it if it's negative, and it's going to stretch it vertically or shrink it. This h inside is going to move the parabola left or right. This k is going to move it up or down. So we call this vertex form. And the form's real handy because if we take an equation, something like this, we have f of x equals negative 2x minus 3 squared plus 4. So we know that this negative is going to flip it upside down. The 2 is going to stretch it, make it a little steeper. This minus 3 is going to move it to the right 3. Remember, it's opposite when we're going left or right from what we would expect. The plus 4 is going to move it up or down. So since it's gone right 3 and up 4, we know that the vertex, which is usually at 0, 0, the vertex is going to be at 3, 4, because it's moved right 3 and up 4. So as we can see, if we can get a function in this form, we can see that the a value is the parameter that changes the shape of the graph, and it changes the vertical stretch. It flips it upside down if it's negative. We know the h is the left or right, so this is the x coordinate of the vertex. It also tells us the axis of symmetry. As we can see down here, the axis of symmetry is x equals h. And the k value is the vertical up or down. So the vertex is just going to be hk. So to see how vertex form works, if we have we want to find an equation of a parabola that's twice as steep as y equals x squared, and it's moved left 5 and down 14. We can get that equation easy. We just need a 2 on the outside. We need a plus 5 on the inside. That moves left, and minus 14 to go down. And to flip this around, if we want to describe this graph, well, we know that we have a negative that's going to flip it upside down, flip it vertically. We know the minus 18 is going to move it right 18, and the plus 9 is going to move it. And that will give us a vertex, since it's moved right and up. We get a vertex of 18, 9. And as we saw in the vertex form up above, this number here, 18, and the 9, that's our vertex. Notice that the vertex form is x minus h. So the reason why we write it that way is so that the whatever this number is here, h, that is the vertex. Okay. Now, if a quadratic function is not in vertex form, we need to change it into vertex form, and to do that, we need to complete the square. So we're going to have a real quick discussion about what completing the square means. So take a look at this square over here. We've got it broken up into some pieces, and we want to think about the area of this square. We want to find the area, find an algebraic expression to describe the total area of this square. Well, it's a square that's x plus 3 by x plus 3. So we know area is length times width. So x plus 3 times x plus 3 is just x plus 3 squared. All right, that's nice. Well, now what if we look at the pieces? We want to find it a different way. Well, we know that this square is x by x right here. So it's x squared is its area. Over here, this little sliver is a 3 by x rectangle. So it's 3x. This is also 3 by x. So it has to have an area of 3x. And this little guy over on the right, this is a 3 by 3 rectangle because of the 3 up here and the 3 over here. So that has an area of 9. So if we take all the pieces, we know x squared plus 3x plus 3x plus 9, and we can simplify that to make it x squared plus 6x plus 9. Now this should be nothing terribly new, hopefully, but we can see that x plus 3 squared is equivalent to this expanded version here and this simplified version. So we'll call this the factored form, x plus 3 squared. We'll call this expanded and this simplified.